objective describing the angle relationships formed when two lines are cut by a new thing called a transversal. We've already been talking a lot about angle relationships. Now we're going to talk about lines when lines are intersecting within this thing called a transversal. Right? So let's start with our vocab. So alternate means switching. If you think about like sports, if you play a sport, it's like, oh, you have to have an alternate put in because someone gets injured or something. Think about it like that, or like switching players. It can also mean like opposite from geometry, location-wise. Interior versus exterior means inside versus outside. Consecutive means in order. When we count consecutive order, 1, 2, 3, 4. Corresponding means matching. You can think of that like if you go to, I don't know, Target, in sweatpants, and you like the corresponding sweatshirt. That's like the match. Like linear pair, we've been talking about here a lot. So that is when, we've got a line, right? Line to end is going to measure 180, right? Half circle. Linear pair is when we have another angle on that line, and then like two angles. Angle 1 plus angle 2. What do you do? We've got two adjacent or connected angles. Vertical angles are formed in lines, straight lines intersect, and they are those angles that are across from each other, like, and they're reflections of each other. So, here and here, and then here and here. Notice I'm putting congruency marks to show that these two angles are the same, and the angles to the left and to the right are the same. And then parallel is going to come into play today, and that is with two lines or segments. Look like examples in parallel lines because they never intersect. Okay. Let's talk about it. Transversal. Actually, let's back up, okay? So this is the picture of transversal. You guys have seen this picture before, right? Where we've just talked about two lines intersecting, and we've talked about the angles that are within in this picture, right? Like 1 and 4 and 3 and 2 are those vertical angles, right? And then 1 and 2, 2 and 4, 3 and 1 and 3 are angles. Okay? Now because we have a line in two lines, we call that a transversal. Transversal is a line that intersects two or more lines. So in this line, label it as T. You can call it transversal something other than T, but this line is intersecting line L1, line L2. It's intersecting those two lines. Okay? And that's called a transversal. And then what happens is this these 8, okay, and they're numbered here. There's my little penguins on, okay, little buddy, okay. So that's the angle, right? He's standing in the angle measure. The angle doesn't measure 1 though. It's using a 1 to say that, like, hey, here's an angle here, here's a second angle here, here's a third angle here, here's a fourth angle here, 5th, 6th, 7th, and 8th angle over here. With this picture, there are 4 new types of angles. Okay, and so we're going to talk about this. There are angles called alternate interior angles. Those are angles that are two angles that are inside intersected lines on opposite sides of the transversal. So when I say inside intersected lines, the lines are my intersected lines. So we're talking about the angles 3, 4, 5, and 6. Okay? And those angles are, you might be tempted to do like 3 and 4. Because 3 and 4 are inside the intersected lines, they're on opposite sides of the transversal, the pink line, right? One's on the left, one's on the right. However, 3 and 4 already form a linear pair, we talked about up here. We're not going to call them alternate interior. Instead, it's going to be 3. If we're talking about angle 3, what angle is inside the intersected lines on the opposite side of the transversal? That's 4. Oh, it's 6. 3 and 6. We call alternate interior. 5 and 4. We call alternate. Okay. Another angle is called alternate interior. So these are two angles outside, interior, intersected lines on opposite, alternate sides of the transversal. So what we do with all about these is like means that they're kind of telling you where in the picture these angles are. Okay? And so alternate can tell you on opposite sides of the transversal, and then exterior tells you those are outside intersected lines. When I say outside, I'm talking about this space out here. 1 and 2 and 7 and 8. Okay? So those angles are 1 and, you might be tempted to say 2, but again, 1 and 2 are a linear pair. So 1 and 8. And then 2 and 7. All those angles in those positions. Okay. Next is the interior towards me. Those are 2 angles inside the intersected lines, no interior, and then on the same side of the transversal. Kind of the meaning of the okay, so those are 3 is on the left side of the transversal, so is 5 on the same side of the transversal. So they're both to the left, and they're inside the intersected blue lines. So 3 and 5, and 4 and 6. Those angles. Okay. And then lastly, corresponding. These are 2 angles that have a similar position, a matching position. Okay, so if I look at angle 1, I notice what angle 1. It's to the left transversal and it's above the intersected line. Where is another angle in that spot? Okay, also left of the transversal, the pink line, and it's above the blue line. So they're in that similar position. So 1 and 5. It would also be 3 and 7, both to the left. They're both under the blue line. Both to the left of the pink line, both under the blue line. 2 and 6. Both now to the right of the blue line, and both above the blue line. And then 4 and 8. They're both below the blue line and to the right of the, okay? So these are our 4 new angles, okay? Other 2 angles, linear pair and vertical angle, just still exist in this picture. 1 and 4, and 3 and 2, the vertical angle. We already talked about 1 and 2 and 3. 4. So okay, got now 4 new pairs. See in this picture. Okay? So I'm going to jump to page 3 now. We're going to talk about the measures of these angles. Right? So, you need to know about this picture. If a transversal intersects parallel lines, then some stuff is good. Right, so let's look at the picture before I tell you. Okay? If I look at this picture, I'm told, given, and this means parallel. Right? So how we can know lines are parallel are 2 ways. 1, we're told using this symbol. Okay, the 2 lines I'm just standing straight up. That means parallel. Symbol for parallel. Also, these symbols on lines, these little arrows, little carrots, mean that lines are parallel. So I'm going to say the given F is parallel. Okay. We're also told the measure of angle 1 is 100 degrees. We're told to find as many angle measures as you can. Okay, so we just go off what I know before we like to talk about these key points. So I'm noticing the transversal. Let me just use what I know though from the past. So I'm going to cover up the bottom intersection and just focus on this first intersection, right? Where I see that 1 and 4 are vertical angles, they're the same. So this is 100, and then 1 and 3, or like 3 and 4 are a linear pair. So I have to add up to 180, 80, and then this would also, right? We've seen this picture before, okay? Now, think about it. If these lines are parallel, the blue lines are parallel, they are crossing, they're like intersecting the transversal in the exact same way, right? It's like the exact same intersection is happening. You can almost think of it as relation. If I were to slide this down here, if I were to slide, okay, slide this intersection down. Whoa, it's the exact same intersection. The exact same thing, right? So I get to copy this is 100, 80, 100. Same pattern of angle measure. Okay? Now, if this, yeah, okay? So let's look at what's happening with those new angle pairs that we talked about. Our corresponding angles, so 1 and 5, right? 1 and 5. So I noticed about 3 and 7, which are corresponding. They're both 80. 2 and 6, both 80. 4 and 8 are both 1. What am I noticing about corresponding angles? They are congruent. The sets are congruent. 1 and 5 are congruent to each other. 3 and 7 are 80 and 8 is congruent. Okay, what am I noticing about my interior angles? That's the angles that are 6 and 5 and 4. Okay, noticing those sets, 80 and 80 and 100 and 100, those sets are congruent. The corresponding angle sets are congruent. The alternate interior angle sets are congruent. Notice that 108, or sorry, 1 and 8 are both 100, and 2 and 7 are both 80. Again, I'm noticing those sets are congruent to each other. And congruent means like measure. Right, we're talking about consecutive interior angles. That's like 3 and 4 and 6. So different. 3 and 6 are different. 4 and 6 are different. Angle measure. 80 and 100. Okay. So, can't say they're congruent, but it's geometry-wise, 180, 180, 100 at 180. So these are supplementary. Okay? So this pattern will always be true if a transversal, or the transversal one is the pink one, intersects parallel lines. Okay. Look at another thing. So, all right. So again, measure of angles is 85. So let me label that. This is 85. Okay. Find as many angle measures as you can. Okay. So I am noticing a transversal. I know there is a transversal. Well, let's say C and H. Do I have any evidence that they're parallel? Nope. I didn't see this symbol, right? See that symbol, right? Don't see the carrots like that on the. If I have no evidence that they're parallel, oh, I'm going to edit them into. So, find as many angle measures as I can. Well, I can still use what I know to be true about vertical angles and linear pairs. 4 and 6 vertical are congruent. So I can fill that in with 5. 6 and 7 make a linear pair. 7 and 4 also make a linear pair. So they have to add to 180. The 95 degrees then. 95 plus 80 is 180. You could subtract 180 minus 85 to find that. Okay, and then again, using either 7 vertical or linear pair with 4 and 6. Right? Next, am I allowed to now do the intersection pattern and like bring it up here? I'm not. The lines are not parallel. I'll actually show you with the patty paper how, like, you might be able to see it, but like, the trace transversal. And if I bring this intersection here, so if I translate this on the transversal, we can see it looks really close, but like it's definitely not totally the same. Notice this line here doesn't touch the blue line. So that means the angles are going to be different. Okay? So as of right now, like not allowed to compare with 1, 2, and 3. We don't know their measures, and that's okay. Let's find as many angles as you can. All we know about this picture so far, like getting out of the intersection, is intersection down here. Okay? So that's all we can. We're gonna move on with it. Actually, let's write down this note, okay? G is not parallel to line N. Okay? So you can only find the angles in the lower intersection using vertical angles and linear pairs. That easier? Okay, maybe. All right. Not parallel line N. So, or no, line G is not parallel to line H, so you can only find this lower intersection. You can only find the angles in the lower intersection using those in linear pair. All right? Is a picture that looks like this. When x equals 40 degrees, this angle is 3 degrees. Let's find y and z. I also need to tell you that y is not, I've got a table there, that y equals 30 degrees. Okay? So y equals 30 degrees. So, okay, well, a couple things. First of all, segment AB and segment CD are parallel. Why? Because of those little curves. Okay? And then I'm noticing sort of a transversal. I'm noticing just one set of intersecting lines here. This doesn't go like all the way. I can imagine going all the way with like a dash line. It like helps me see some stuff. And then in this picture, we have a second transversal, right? That goes like line rather that's intersecting down here. And then if I wanted to continue imagining the transverse, making it a transversal intersect this line, a little dash line. But in this picture, it is adding something called an auxiliary line. Auxiliary line. That is an extra line that is parallel to the given. Okay? I'm going to imagine, I'm going to put it here, and you'll see why in a second. This is an extra parallel line. That's my auxiliary line. Dash. It. Okay? And so what that helps me is now I've just kind of created a couple extra mini transversals within this picture. Okay? So I have created green transversal now created down here by, if you imagine the green intersecting, like my green marker intersecting ED and then my auxiliary line, right? And then I've also created actual transversal with the pink line intersecting the two AB line here. Like, now I can use this for filling an angle measure. Because here I go, right? Geometry is a puzzle. Puzzles are fun. Let's do it. So I'm just going to start filling in angle measures based on what I know. So the goal is to get what? Z. Yeah, we already know why I gave it Z. Okay, so I'm not in here. Angles, dope, that's pretty. Okay. Noticing here, ultra interior angles. They're inside the auxiliary line and CD. Angles are the same, so that gives me half of Z. All right, go here and see if I can fill out the rest of it. Let me do it a different way. This has to be 140 because it's a linear pair. And then I'm noticing these two are consecutive interior angles. This angle, that are consecutive interior angles on the pink transversal. So they add to 180. And so this has to be 40 degrees. And so what is Z? 40 plus 30. Z is going to equal 40. 30 is 70 degrees. That was one way of accessing that, right? There was a bunch of different ways you could access it. You could fill in Z and like a bunch of other angles. Okay, kind of get to choose. This is what about geometry. Okay, and that's it. Hope that made sense. Hope you enjoyed it. Here's this little penguin sending you some love in your math lives. Yay. Have the rest of your day.